Hey everyone! In this video we're going to have a look at how to use Houdini VEX to create a custom deformer for character rigging. So the first question would be, why use VEX for character rigging? I like to use it simply because it's fast and flexible. And it's easy to implement. It is very fast to make changes. And we can instantly see the results as we change the code. And since VEX is very fast, the rigs are more responsive and animators want fast rigs. So from the rigging point of perspective, VEX is a great tool. With this in mind, we're going to create a simple deformer, which I simply call a drop-off deformer, which will transform the geometry based on pivot point position and distance fall-off, both which can be animated by the animator. But first, let's see what we are trying to achieve and how the deformer should work. This deformer should allow distance-based deformation based on radius and a ramp, which this ramp will be used to shape our deformation. Or how is shaped this fall off from the center of deformation, and another control which dictates the center or the pivot point of our deformer. First, let's create the controls. We're going to need three nulls. One will be for the positioning of the control, and one for the pivot position, and one for the actual deformation control. So let's go now and go drop off position, and another one which will be parented under this drop off, which will be pivot. Drop off pivot, and another one which will be parented under drop under pivot, which we'll call drop-off control. So now we need to place our controls to correct position, which should be someplace around here. Okay, we'll hide the drop-off position, and for pivot, we'll just move it or scale it down first, change the icon, and just move the display center. And for the drop-off control, change the icon to circles. Okay. So here we have a pivot control and the drop-off, the actual deformation control. So what we'll need is add a few parameters. So the first information that we'll need is the actual pivot position, which will be the sum of our drop-off position translation and our drop-off pivot translation. So we'll add these parameters to our null controls. Call it rig. Add float vector and name it pivot pass. Pivot pass accept. So as said, this one will be the sum of our drop-off position translate and our drop-off pivot translate. Now that we have our drop-off pivot position, which can be animated by our drop-off pivot control, we need also to add our default pivot position, which is basically just a drop-off position translate. So we'll just add another float vector tree and call this default pivot. Let's say default pivot. And this one will be just the translate. Okay, so now when we move the pivot position, we know we are getting a different where the center deformation will be. Now for the control, we're gonna need two parameters, and one is the deform radius, which tells us how far this deformation will go, and one ramp parameter, which will be a curve dictating how this deformation will fall off towards the edge of this deformation radius. So edit parameter interface, let's add a folder called rig. Now add float parameter, which will be deform radius, and one ramp float parameter, which will be deform fall off. Okay, and we're gonna reverse this because you want the largest deformation at the center, or at the beginning, and to fall off towards the end. So we can do any kind of curve here, and let's just say deform radius to 0.1. So okay, so now we need to set up how these controls will deform the geometry. So first, let's create the group, which will be our deform points. So in this group, we are just selecting basically the points that we want to be affected by our deformer. We're going to use transform sub as our deformation. And we're going to use information from the drop-off pivot and drop-off control. The pivot position, I'm going to use it here. So copy parameter, and say paste relative references, and from the drop-off control we're going to use translate, rotate, and scale, and just paste relative references, just scale. Okay, so, and set the group type to deform points. Okay, so now we are deforming everything, of course. So now we need to set up our wrangle. So we're gonna use two wrangle nodes, one which will actually set the deformation value, or how much this transforms up here is gonna affect the geometry, and the other one which will actually make this deformation. So let's create an attribute wrangle, rename it to set deform value, and for the group let's set deform points, and we're gonna just add attributes that we're gonna copy from the controls. So radius, deform radius, pivot point, and the fall off ramp. So hit parameter interface and just add a float, which will be our radius or deform radius. We're gonna add the float vector 3 for pivot position, and a float ramp, which will be our fall off. And now we'll just copy from the two controls, the pivot from drop off pivot and the radius and fall off ramp from the drop off control. So copy parameter and paste relative references, and from the control copy parameter, relative references, and for as well for the ramp. Okay, so everything is now connected, so now we can use this to write our VEX expression. So first, let's set a deform value variable. So this one will tell how much each point should be affected by our deformer. And let's say float radius, and so we are just getting our parameters into our expression. Now we need to calculate the distance between each point and the pivot position. So float pivot distance is distance for point and pivot. And now if our distance pivot is less than radius, then let's set deform value. Our deform value will be based on our fall off ramp that we created, and it will tell us how our deform value is falling off towards the edge of the radius. We'll say float ramp position and say fit, and we'll say pivot distance and 0 in the radius and 0 and 1. So we are remapping our distance value between 0 and 1. Say deform value is ch ramp. So we're looking at our ramp from this fall off curve and see what our deform value should be. So value and ramp position. And now we have stored how much should we deform our point. Okay, if it works correctly. So now we can create our second wrangle. So wrangle and say set position. And we're gonna take our deform value, and for the second input we're going to take our transformation. The group should be set to our deform points, and let's deform only those or check only those that have deform value more than 0, and say parameter deform p. And you okay, oops. So what we are doing here is we take our deformed position, or the position of the point from the deformed transform sub, and apply it only so much as it is dictated by our deform value. There's just a slight error here. Here's a flow pivot. Change this to vector pivot because it's in a vector. And now we can check how this works. So, okay, we move the control and it works. Now if we change the pivot position, we should change the center of our deformation. And this is basically how this Dropoff deformer works. We can also change this deform radius, and we are affecting a larger area or smaller area, and we can also change our deformation curve, so it can have a sharper edge depending what we are trying to achieve. And that's pretty much it. This is a simple deformer using VEX. Once we are happy with how our deformer works, there's just one last thing that must be done before we put our deformer and controls into a rig, and that is on our drop-off pivot control. We should delete the expression on our default pivot position and lock the parameter. This is because our drop-off position will be parented under bones or any other object in the rig, and these translate values will change, and we don't want that because this default pivot position should never change. Also, the pivot position parameter should take now the default position parameter instead of drop-off pos null translate. So here I would just like to note how everything fits into a rig, and here I'm using this Dropoff deformer as a cheek deformer, and I parented the position null under this head bone, and this head bone is actually deforming the whole head, so these controls move with it. As for the actual geometry Dropoff deformer, we'll go into the face geometry, and I'm using this Dropoff deformer. Here we have cheeks, basically as a blend shape. So here we have eyelid blend shape, brows blend shape, lips, and all these are working as a blend shape here, and everyone is deforming its own region, but together they fit as a blend shape. So if we go into cheeks, we see that this is basically our deformer, and left and right, and in a whole rig this acts as a blend shape that is always on, and this way it is very easy to add this kind of deformers into existing blend shape systems. So that's it for this video. Thank you for watching, and hope to see you next time. Bye bye.